Hi. Today we are going to talk about sequences, which is a mathematical way of describing data that comes to us in the form of a list of numbers. And I think the best way to introduce this topic is just to look at a specific example. Okay, so you can see example 1 in front of you here. Let's just read this problem together. So suppose that you invest $10,000 in an account that earns 5% annual interest compounded monthly. At the end of the nth month, let AN be the total amount of money in your account. Okay, and then they start talking to us about this table of values to the right. And you can see two columns here. One column tells us the interest that we're earning, and the second column tells us how much money we have in our account. You can see from the first row in the table that we start with $10,000 in our account. Okay, and during that first month, we don't earn any interest. And then after the first month, we do earn a little bit of interest, and our account balance goes up after we add the interest in. Okay, and the data that you can see in the table already is kind of what the bank has done for us. They've calculated the interest and added it to our account each month. What I'd like to do is to see if we can fill in the last two rows of the table together. Okay, how would we do this? Well, if you look at the fourth month, we have a balance of $10,167.71. We need to figure out how much interest we earn, okay, in that fifth month, and then add it to that balance, basically. All right, so notice that in the problem, they told us that we earn 5% annual interest. So the interest in 1 month is just going to be 1/12 of that, since a month is 1/12 of a year. Okay, so we basically just need to take that 5% and divide it by 12. Okay, I'll write it as a decimal. All right, so if we figure the interest earned, okay, during that fifth month, we would start with the $10,167.71. Okay, and then we're just going to multiply it by that interest rate of 5% divided by 12. Okay, and you can do that calculation on your calculator, and what you will come up with is $42.37. Okay, that is the interest that we earned during the fifth month. Okay, and the idea is we want to just take that interest and add it to the amount that we already had in our account. Okay, that's this $10,167.71 again. So we'll start with that. Okay, and we'll add in the interest calculation that we just made above. All right, and you can do that calculation on your calculator as well. And what you will come up with is $10,210.08. Okay, so if we add the information that we just calculated to our table, we got an interest amount of $42.37, and that brought our overall balance up to $10,210.08. So we filled in the second to the last row of the table. Okay, now we just want to repeat that idea. Okay, so in the sixth month, now we're starting with our amount of $10,210.08. We're going to figure out how much interest do we earn from that, okay, by doing the same calculation that we did above. Okay, add. Okay, we want to take that amount and multiply it by 1/12 of 5%. There's another calculation that you can just punch into your calculator, and what you will get this time is $42.54. Notice that the amount of interest is a little bit higher than the interest that we earned at the previous step. Okay, and that's the interest that we earn in the sixth month. Okay, and so now we want to take that interest that we earned and add it to the amount that was in our account at the previous step. That was the $10,210.08. Okay, plus that interest that we earned in the 6th month. Okay, and if you do that calculation, you are going to come up with $10,252.62. Okay, we can add those two numbers to our table again. During this month we earned $42.54 in interest, okay, which brought our total up to $10,252.62. Okay, and we can kind of look at these calculations sort of in the big picture now, and just notice in the second column here in our table, our account balances are going up, and this is a very regular process. We could keep doing this calculation over and over again and figure out month after month how much money we have in our account. Okay, and you might look at these numbers and notice they appear to be getting bigger and bigger and bigger. So this list of numbers, this list of account balances just keeps growing as more and more months go by. Okay, so we could maybe summarize this discussion by saying that this sequence, that's a new word for this list of numbers. Okay, A1, A2, A3, and so on. Okay, will continue to increase. Okay, so what we have just described is a new mathematical object called a sequence. And you'll notice at the bottom of the page here, we have a formal definition of the concept of a sequence. Let's talk through this together. Okay, so a sequence is just a list of numbers written in a definite order. Okay, here we're using the notation S1, S2, S3, and so on. Same idea as above, we just happen to use a different letter of A for our account balances. Okay, and our textbook likes to use this notation for the overall sequence, just a bracket, SN. That's a way of just talking about the entire list of numbers as one object. And we'll kind of see how we use this notation in our future examples here. One thing that we'll be very interested in is the idea of convergence of a sequence. Okay, and that is really the same concept that you learned about when you talked about limits in Calculus 1. To say that a sequence converges is just saying that that list of numbers is approaching some number. In other words, if we list more and more numbers, we would say that the sequence converges if we get closer and closer to a specific value. Okay, and we will see examples of that also as we do further examples in this section. Okay, and since this idea is so similar to the idea of the limit of a function, we're going to use the same notation to describe sequence convergence. Okay, so if you look at this sentence right at the bottom, okay, sorry, I'm having a little bit of trouble with my pen. If the sequence Sn converges to L, we're going to write that down as follows. Okay, so the limit as n goes to infinity of the sequence Sn equals L. In words, all that means is that that's telling us that this particular sequence, as we go farther and farther out, take more and more terms, those terms are approaching this number L. Okay, and again, we will see further examples of how we might do this calculation and figure out whether a sequence converges or not.